Yes, hello again. Now this is maternity sub. Okay, this is another document, and you can see that there are many hospital here host variable, host one variable, host two variable, and there are some explanations about it. Here you can see, and there is cigarettes per day, there is parity and parity one, lots of other measurements, and this time we have labels: weight of previous baby, maternal height. You can see all the labels are written here, and there are 28 variable names. So name of this data set is maternity, you can see it at the top, and there are 28 variable names. Now let us see whether they are defined correct or not. Sometimes this is a problem, but this time it seems like that they are okay. We will see. Let us see first of all this data set. You see that this should be nominal, okay? This is nominal, you can see it nominal. This is nominal, nominal from the symbol here. There are three circles. This is red, green, and blue. And this again, and the other one. So these are all nominals. These are, you can see that these ones here are ordinal, okay? They are in order, and these are scale. How do we understand from this ruler sign? These are scale. By the way, we have some missing variable here. When you have some missing variable, they are represented as dots. You see that there are dots, okay? And here again some missing variables. This is an ordered variable, you see it from here, and these are scales. This is nominal, this is ordered, this is ordered. There are 28 variables. Okay, how many patients? We can go like that, but the easy way is that to find frequency. Analyze descriptive statistics and frequencies. Let us export this data set, this maternity data set. I take all of them, I select all, I pass it to the right side of my window here, and I click OK. Now I am going to find output. I have yes, here. So I have different here you say different frequencies here. Okay, these frequencies are the frequencies that how many people answered these questions. So how can I understand how many people are there in my research study here? How many patients? The highest number here is the number of patients who attend to this research study. So here you can see that there are 296 patients, okay, because this is the highest number. But length at birth, we know only 148 patients length at birth, okay, and here her circumference at birth, we only know 287, so the others are not measured. Blood loss, so we have some information about this. The information is 296 people give us information about the amount of blood loss during the birth. Here this is the birth weight, and this is cigarettes per day of the mom who is taking how many cigarettes per day, and this is the realistic, so all the other information. So here you see that there is one missing. One is not, one mother didn't answer whether she was smoking or she's smoking or not. Here 148 people didn't answer, or the nurses didn't measure the length of birth of the child. Here 9 nurses didn't measure the head of the circumference. So these are the missing information here. And again, in health, sometimes it's possible to have missing information. Some, you know that when we go hospital to have blood tests, doctors don't write all the blood tests every time. Sometimes they give you 2 tubes of tests, you do 2 of them, and sometimes they give you 5 or 6 tubes of tests, so you do more tests. So if you do the test, then you write the result here. So here some tests, some measurements are not done, therefore we don't know it, and if we don't know it, then we just write missing. And these are all the other frequencies related with it, and also percentages. This means that weight of previous baby, if mom has 2 babies, weight of the previous baby, you can see the weights are here, and how many babies have this weight and how many babies have this weight. You can see the frequencies here. Yes, these are frequency tables. So how many patients are there in our study? By the way, this is other, yes, this is at the top. I didn't delete it. I can delete it from here because this was all before. And now, this is our current data set. Now I have it everything here. So if I want to delete anything, I can delete it from this side also, or I can select and I can click delete button to delete it. And I can save this output also. Let us see how can I save this output and what is its extension. I can save it to my desktop. I put it in new folder, I think. Yes. Okay, I'm going to save it here. So this is maternity. Okay, now look at the extension, SPV. All SPSS documents output are SPV. Okay, this is an output, and output is SPV, and normal data set is SAV. Now look, this is an output, this is a document. So we have 2 different windows, 2 different documents. One of them is SPV, the output document, and the other one is SAV document. Okay, so here, this was the maternity. I have some other open SPSS documents here. Let me see. These are the dosages, performance, and group. You can see it. These are all scale. And here, let us look how it's defined. Group is defined as nominal. Interesting, nominal. Let us see, but it's missing. This is not finished. Maybe it was good always defining group in here as groups 1 or 2, and also writing this should be numeric. As I said, examples that I am going to show you what is true and what is false, what should be done. Yes, and again, you see that there are patients. Here, how many patients? The method is same. Analyze the statistics, frequencies, and let us have all of them to the other side. Click OK, and let us see the output. By the way, I have the maternity one open, and when I have it open, sorry. Yes, this is the other one. You see the output come at the end of it. So if I don't want this output to be here, I can either undo this. So all output is closed. I should close this one. So if I close this one, it will open me a new output page. It may seem complex to you, these parts, but don't worry, they are not really complex. Here the logic is saying we write analyze the statistics frequencies, and I'm calculating the frequencies here. You see that there are 400 patients, and okay, so here I didn't write group here, so therefore this group is 0. All the data are missing here. So while it's 400, so this means that there are 400 patients. So I'm going to close this, saving this time. I don't need it, and I'm going to open another SPSS. So let not close it. It will stay here when I close it. There is another one. This is related with keratin clearance per 1.73 meter square months before dialysis. So you can see that we have 3 different variable names here. 1, 2, 3 different variable names. And to find how many patients, again, analyze descriptive statistics frequencies. I have everything to the other side and click OK. And I will have my output here. Let me see this one. So this time I have 86 patients in my study, and nothing is missing. You see that there are explanations. All the labels are written here. All the labels are written here. So it's important to have labels to see them on output. This one, okay, these are the variable names. So there are labels, so it is right on the output. Now look here, the groups. There are different grouping system here. By the way, we don't need this decimal points 00, so it's not good defining like that. So we should have this 0. So it's enough if we have group 1, 2, 3 like this is better. Okay, so there's no meaning of .00. Okay, so here this is bigger than 24, and this one is 21 to 24. This is 18. So these are all the intervals. Okay, but these intervals are not exactly same. See, they are not in order, but it is in reverse order. So for example, this is smaller than 3, and here this is bigger than 3, and this is bigger than, so the ordering may be confusing really. So the highest group number, the general way of describing this, the highest group number should be the highest, here this should be 9, okay, and the other ones should be 1. But if I so I can define it like that, this is 9, okay, I can change it, and yes, okay, so all the other ones, so the biggest group number should be 9, and then the smaller 8. This is the general way of it. Yes, now let us see some examples of parametric tests and non-parametric tests. Okay, so with parametric tests there are t-tests, okay, which are widely used. T-test. And with this test, t-test, there are 3 different kinds of tests. One sample t-test, and there is independent t-test, there's independent t-test, and there is paired sample t-test. There are 3 different types of tests. I'm going to show you when and how they are used. Yes, and there is paired sample t-test. Okay, and we'll see non-parametric later in detail. Today let us see parametric ones and not to mix everything. So parametric ones are the normal distributions. Okay, we have seen this until now, and also equal variances. So these are famous tests that are done, that you can see in almost every study, especially the independent test, which is done between female and male. You can find it very common in your researches. Okay, so also, but these ones, now one sample t-test is when you have only one variable. When you have only one variable and you want to compare it with only one variable, and when you want to compare it, with a constant value. For example, here let us say blood test of people is below 1 or 11, let us say 11. Blood test below 11 or above 11. So this is a standard number and this is the variable. Okay, so if it is a variable, the variable name cannot have an empty space. So we write it on a statistical program like blood test without any space. Blood test, for example. So, or let me give you another example. Cholesterol less than 190. Cholesterol. No suggestions. Okay. Less than 190, let us say. So for this kind of purposes, we use this test. So for finding how many patients have cholesterol less than 190, this is a constant number, it can be anything else, okay? So it depends on our research study. We will see also hypothesis soon, but let us finish this. Also, independent t-test is finding difference between two independent groups. Okay, finding if there is a significant difference between two different groups. Okay. So this is finding if there is a significant difference. And paired sample t-test, here you can see this paired sample t-test is finding if there is a significant difference between repeated measurements. For example, blood tests in August and blood tests in September. Between two repeated measurements. Okay, so good. These are how we use it. Now we are going to see lots of other examples of this. Let us see what is a hypothesis and how do we set up an hypothesis. Okay. So, hypothesis is the idea in our mind when we start a research study. When we start a research study, we have an idea whether the blood level will be above 190, or we have an idea that girls are more successful than men, for example, or we have a beginning idea like female have more dentist fear than male, for example. So every researcher has an idea in her or his mind before starting an experiment, a research study. Or maybe that we have an idea that, okay, this medicine will be useful for this diabetic people, okay? So we have an idea. So, or this painkiller will be better than the other one in this for this type of patients. So writing the idea, expressing the statistical way of expressing what is in our mind is hypothesis. We express ourselves in sentences. For example, a hypothesis: female. There are two hypotheses, by the way. H0 is there is no difference hypothesis, and the other one is just the opposite one of H1. H0 and H1 are two opposite hypotheses. No difference. Okay, generally, or maybe that it's not exactly what we have in our mind. Not we have in our mind. We never deliver a research study that a medicine have no effect on patients, but what we expect is that this medicine is have some effect, have good effect. For example, these days lots of vaccine for COVID-19 research experiments are going on in all the countries, and they are trying this vaccine with different patients, and they are testing whether it's useful or not. But before doing that, before starting this thing, they have something in their mind. Okay, this vaccine will be effective. Okay, if they don't have anything in their mind, they don't study a research study. They don't start doing it. They haven't, but they have an idea in their mind. But for proving it, especially in health, we have to do tests. You know that okay, we found this vaccine is good, but we have to do tests, and we have to test it on animal, then human beings, and after trials we can say that okay, this is good. So the idea in our mind is H1, and the idea opposite of our idea is H0. Okay, this vaccine will have no difference, okay, will have no effect. And H1 says yes, the vaccine is good and will be effective. H1 have difference. Okay, so one example, for example, female have just a moment. The dentist fear score of female is higher than male. Okay, let us say this is our hypothesis. Okay, or there is a significant difference. We can say there is a significant difference. By the way, this word is important in statistics. This is a keyword, and I will explain you in other courses why it is a keyword. You will see this in many studies. Some people are using it in the wrong meaning, but it is a powerful keyword expressing some kind of research findings. I will explain it later. Then there is a significant difference between female and male dentistry, between this of female and male. We can say this one. And we can say H0 there is not any difference. So H0 is there is no difference. There is not a significant. That's the difference. So this may seem complex, but you will get used to it. So this is the idea. H1 is always the idea that we have some idea in our mind. There's a difference. And H0 is, okay, there is not any difference.